Okay, Assalamualaikum and very good morning. So we will continue from last week class, on using R. Okay, of course, most of the notes in R may be too deep for you because you just want to use it. Yeah. Where did we stop last week? Have we gone through this? I forgot. Have we gone through the basic operators in R? Anybody remember? Okay, tak apa. Okay, so maybe we just continue a little bit. In R, okay, we have basic operators. Okay, if you remember for the data structure, okay, for the data types, before for the data type, we have different types of data type is being classified in R. Numeric, real number. That means when you have decimal, and actually integer is also part of numeric. It is a subset of, So if you want to really declare the number has integer, we must write L, like 15L, for example. Okay, and then we also have true and false, logical types, atau boolean. And then for character or string or text, and then we have complex numbers. So these are the different types of R data types, And then we can use the function class, or class to know what type of data you are dealing with. Sometimes when we do analysis, it is important to know the type, the data type. Okay. Somebody need okay. Okay, so we use class or sometimes we use str for the structure. Okay. And then if you want to check what type of data type, we use is dot what we specify the type of data of our numeric, integer, and so on. Okay, and we can also change the characteristic of the data type. Has numeric, has integer, has character, and also has logical. We can change that. Okay, so cohesion rule in R, if we have a logical, we combine with integer, it become integer and so on. So if you look at in this example, the integer combined with the text, logical combined with the character, so it become a character. Okay, so you can try this to check what is the class of the variable. So we are going to go through fast and forward. So okay, I'm going to use our script, but you can use our notebook. Did everybody remember how to use our notebook? How to open our notebook? Is it okay? To open our notebook, just file, new file, then you go to our notebook. Okay. Remember I said this part don't touch, line 2 and 3 do not touch. So you can just write your name here, let's say Roslina, and then put a backslash to go to the next line. Let's say my ID, let's say ST maybe 24007. And then this is statistical modeling course, for example. Okay, and then I can put my codes, okay. Okay, and actually I can put more Control Shift Insert, sorry, Control. Okay, to separate this, yeah. Sometimes it is better to separate this. Yeah, so that you can see the answer clearly. Control Alternate Insert. Yeah. So when you do the work, yeah, you do the exercise, you can do this. Yeah, so that you can see the output, yeah, just below it. Yeah. Okay, and then yeah. And then you can write notes here. Okay, for example, let's say data type in R. Okay, then you can run this. Oops, sorry, 33 is not there. Okay, so you can run again. Okay, so yeah, whenever you combine, yeah, C mean concatenate, that means combine, yeah, integer with character. So if you check the class become, yeah, this data type now, this a new data type become a character also. Yeah, so this is based on the cohesion rule. Okay, so similarly for B is so yeah. So this is the results. Yeah, B false and I am Roslina. Yeah, so they become character because when we join a character with a logical, it also will become a character. And we confirm that with when we type class B. We want to know what type of B is. Okay, similarly for D and so on. Okay, boleh. Any question?
Doctor,
Yeah,
can you show again how to write the line on 17? If
9 on
there's
17.
no line, yeah, line 17,
Uh-huh.
how you do that? Because when we see from line 12 and 13, there's no space.
Okay. Dia boleh je delete. Okay. Let's say you want to delete this and then do it again. Wait, okay, letak space and then Control Alternate Insert. Yeah. And you put what you have there, then you can try. Whatever.
Also need to erase
Yes,
lah.
delete first. Because just now I forgot to put a space before that. Okay. So when you okay, good. So let's say when you are done with this, you go to preview, you need to HTML. Okay. Then okay, I need to give the name for this. Let's say I put it in desktop. Try one. Okay, save. Okay. Ini a bit slow, Okay, so it become like this. Okay, so if you didn't put the backslash, this information will become in one line. So that is why there's a need to put one backslash there. Okay, boleh. Is it okay? So you write very nice, huh? It's like you are preparing like macam buku lah, It's well written. So the one in the gray area is actually for the codes, and white area is for the output. Okay, so in between you can write the notes and so on. Boleh? And then you go to, if you want to send to me for the exercise, you just and then you take this 3 dot there and then just print. Yeah. So you print to Microsoft print to PDF, then you print, then it asks you to give a new name. Yeah, let's say, I know, maybe SD 24007 just now. Okay, I put it in desktop to mix up with my files. Okay, then save. Okay, so that will be the file that you are going to send to me. Okay. So, boleh. Okay, so I think you can check. Yeah. Okay, data structure. How are we going to, construct matrices and so on. So this is arithmetic. That means from the data type, we can add and so on. Yeah. We can compare, we can use the relational operators and so on. Logical. Yeah. Okay. Okay, this is other operators. Okay. How are we going to for example, relational, arithmetic. Okay, for assignment, the assignment is also important. There are many ways. Okay, like I said, less than dash is actually the meaning is the same as equal. Yeah, less, and also some people write less dash. Yeah. Similarly, if we write assignment, dash greater than, or dash greater, or simply actually equal to. Yeah. So many people now use equal to rather than less than dash. Yeah, because I'm familiar with that, so that is why I do it. Okay, I use that one. Okay, but you can use equal to. Okay, for relational. Okay, for example, if true, t equal to true, yeah, t equal to true. Actually, in R, we can also write L, but t for true, but it is not advisable, yeah. So normally it is advised to write in full, yeah, true, and capital letters. Okay, and whenever you have exclamation marks, t exclamation mark equal, that means t not equal to, or true not equal to true. So that statement is wrong. Okay. If t not equal to f, yeah, that means it is true lah, that statement. And we can also write 3, is it greater than or equal to 2? So that statement is true. So this is what we call relational operators. Yeah. Okay, what about for the when we have a text, we can also compare. Now, selamat is equal to sihat. Okay. So these two character is not exactly the same. Yeah. So it is false lah. Yeah. Selamat is not actually equal to sihat. It's not equal to. So the statement, the result will be false. Okay. Okay. If hebat greater than cemerlang, okay, so it will look at the first letter in the character when we compare. Yeah. So character that is on the right is considered greater as compared to character on the left. Yeah. For example, cemerlang come first, that come first, or H comes later than C. Okay. So that is why this statement is true. Okay, but if you look at the other one, awesome greater than excellent, yeah, the statement will be false because A is on the left of E. Yeah, so by right, E is greater than, or excellent is greater than awesome, then the statement become true. Yeah, so it only look at the first letter in the word. Okay. Okay, true greater than false, of course, because true take the value of 1, false take the value of 0. Okay, so that is why this statement is true. Okay, the answer. Okay, boleh? Any question? And then this is for logical operators. Yeah, for logical operators. Okay. So let's try this one. X1 less than or dash or simply X1 equal to 5. So if X1 greater than 7, does X1 greater than 7? This is false, and X1 less than 10, this is true. False and true become false. Yeah, for logical N, yeah, for logical operator N, if there is false, it become false. Yeah, so true is true. False and true, dia akan jadi false. True and false, false. False and false, of course, false. Yeah. So we need these logical operators, especially when we do the programming. Yeah. Okay. But in your case, we don't expect you to do the programming. Okay, kita just use it. Okay, the logical operator or, yeah, true. For or, if there is true, it become true. Yeah, true or true, true. False or true, true. True or false, true. False or false, of course true. Of course false. Yeah. When there is false, then it is false. Okay, that is for the logical operator. Okay. So this is and again, if you see the exclamation marks mean not. Yeah, not. So like in this case, X not X less than 5. So the answers will be X greater than or equal to 5. Yeah. So is 5 numeric? True. Not numeric? False. And so on. Okay. So you can try that in your R. Okay, this is more on the symbol of and or. Okay. So this one, it is comparing with the element to element. Yeah. Okay, other operators that we use, that we have in R is the colon. Yeah. If you want to generate a number. Yeah. And then we can also use percent to find the element belong to a vector. Yeah. And for matrix, we do matrix multiplication using the asterisk. Okay, for multiplication. And for transpose is simply T. Okay. Okay, this is an example. We can run this example in R. Okay, let's say we include one more, control alternate insert. Okay, so this one, more operators, for example, or other operators. Okay, maybe we put this different place up. We open a new script so that the output is not crowded. Alamak. Okay. Control alternate insert. Where is it? Okay, if I run this, I'm generating a vector from 1 to 100. Yeah. And also I'm generating a vector, yeah, V2. So there are two sets of vectors that I'm generating. Okay. So this is 97, 98, 99, 100. Okay. This in a bracket show the location. Yeah. Show the location. Okay. Where is it? Okay. I'm going to check this. Okay. Okay. Control alternate I insert. Okay, so this is our V1. We want to check whether 55 is in V1. So the answer will be true. Yeah. And V2, is it in V1? Yeah. So this is the answer. So you want to check whether that particular number is in the vector or not. Okay. It is the second output, yeah, is for V2 in V2 in in V1, yeah, the numbers. Okay, for matrices, we can form a matrix from 1 to 9, and we want 3 rows, yeah. So it will fill up the first column, yeah, and then go to the next column. Okay. So it is by default you see by rows, yeah, by column, sorry, by column through. Okay, and then you can transpose. This is transpose of the matrix. Okay, maybe I can insert a new script and put it here. Okay, so we can run again. So we have a matrix. We are forming a matrix of 3 by 3. Yeah. So it will fill in the by column, yeah, by column 1, and then go to column 2 and so on. That is by default. Okay, and then I can transpose that. Okay, so this is the transpose, and the second one is the multiplication. Okay. Okay. So control alternate insert. So I'll do for the multiplication here. Yeah. So you can separate all your codes there. Okay. So run again this one. Okay. This is the transpose, and this is the multiplication of the matrix and its transpose. Okay. So for example, if you want to find the inverse, so this is multiply matrix multiplication. Okay, so let's see, we want to find the inverse. So we use soft. Yeah. Whoop, tak ada ke? Oh, it is zero, singular. Oh, this is singular matrix. Okay. What if I take this one by transpose? It's transpose. Oh, tak boleh juga. Ya. Okay. Okay, tak apa. Yeah, maybe the matrix that I construct is a singular matrix. Okay. So we are done with R. Okay. Of course, you can explore further if you want. Okay. Now let's move to I think I did give you the latest actually I'm preparing a new set of notes, yeah. I gave you the PowerPoint, right? Actually, that notes is prepared by Dr. Norianti, the PowerPoint one. Okay. But I'm preparing my own notes, but I extended it a little bit to give more explanation. So that's the one that I give you. Okay. I need to open it. So this one, if you want to delete, just delete lah. Yeah. So you can delete. Okay. So let's look at the new. It is actually still in in chapter 1. I label wrongly that one. Okay, so in between chapter 1 and chapter 2, in the apa ni. Okay, statistical modeling using R. Okay, now we have the tools. Yeah, of course, if you are not sure about certain function, you can always Google and then or ask ChatGPT on how to do it using R. Okay. So we are going to look at the statistical modeling using R. Okay, now I add on one topic which I think is very important. Okay, if you have a set of data, the first thing that you should actually to understand the data will be to do exploratory data analysis. Have you heard about that? EDA? Have you heard about EDA before? Hello?
No.
No, yeah. So
No, doctor.
exploratory data analysis, it gives you, a feeling or an understanding, preliminary understanding about the data. Okay, how the data are correlated and so on. Yeah. So when we have the data, and is there missing value or not in the data? Yeah. Any correlation, any relationship between the variables? Yeah. Any inconsistency in the data and so on. Okay, so we do exploratory data analysis before we get into a serious business, yeah, or before we use the statistical models. Okay, and and then we look at the correlation. Yeah, actually, it's part of the EDA. Okay, I will explain in detail, and then we try for simple linear regression and multiple linear regression. Okay. Okay, this is what we aim to achieve. You will be you able to describe data and identify patterns. You're able to calculate calculation value and interpret. Yeah, calculating is not enough. What is important is to be able to interpret it. Yeah, and able to construct, plot, and use simple linear regression model, construct and use multiple, and construct correlogram. Yeah. Okay, so what is EDA? Yeah, EDA stands for exploratory data analysis. It introduces the range of interesting. Yeah, it can be good, it can be bad, or can be ugly. Yeah, features that can be found in data. Yeah, that is the first instance. Yeah, sometimes they say that this is the data preparatory stage. Yeah. So EDA explores data in a systematic way. Actually, it is being introduced by John Tukey et al. Yeah, so this person is introduced the EDA procedure. Yeah. It is used to familiarize with the data to gain a deeper understanding of possible features and relationships. Yeah, in the data. Okay. Okay, steps for exploratory data analysis. Normally, the first step will be to load and view data. Yeah, from there, you can see the data structure. Is there any missing data or not? Yeah, is there any inconsistency in the data and so on? Okay, step number 2 will be to summarize data. Either numerical, that means you find the mean, the standard deviation, and so on, or you draw the graph, using histogram, using box plot, using a bar plot, and so on. Yeah, you summarize. Yes, you summarize the data, and then step 3, you can also find the relationship between the variable. For example, using the correlation value, and the visual, the graph is called correlogram. Yeah, I share you the very nice graph of parallelogram. Yeah, all the codes that we have collected. Yeah. Okay, for example, this one. Okay, I think you better copy and paste into R. Okay, any questions so far? Is it okay? Okay, you continue.
Okay,
Yes, you using our notebook. Yeah, just continue. So I'm going to use our script. Yeah, you all guna apa ni? Okay, so this is EDA. Okay, first step one to look at the data. Okay, can you get the data? Datarium. Actually, Datarium is also in our database. Yeah, I think they put it in one place. Okay, so if you look at our data, yeah, you see that these are the package. Yeah, Datarium, one of the packages. They have data sets. These are the name of the packages. What else? Yeah, there are many data in this. Yeah, use data package and so on. Okay, there's many data in this R database. Okay, so can you get the data? I think last time you did. You need to. Okay, if your Datarium is not there, you need to go to. You need to install through this packages. Install. Yeah, then you type Datarium. Okay, then you install. But since I already have that, so I don't have to reinstall it. Yeah, install, and then to call the data, you just type library. Yeah, so it will give you. Yeah, it will go through the library, and then I'm going to select marketing data. Okay, did everybody get up to this point? Is it okay? Boleh?
installing library, Doktor.
Yeah. Siapa tu ya yang cakap? Boleh tak share? Can you share
Hanif, Hanif.
your... you share. Then kita boleh tengok lah. I stop sharing first. Okay, you share, then I can show you how to do it. Okay, boleh share. Oh, Mr. Maksudul is not here today. Okay, good. So error in the library, there's no package called. Okay, good. Yeah, that's right. Good. Datarium RI. Okay, install. Okay, so biarkan dia dulu. Wait. Okay, then you go to library, run your code. Okay, good. You got it. Boleh? Boleh?
Boleh, Doktor.
Okay, good. Okay, now head mean what do we mean by head? Okay, you boleh buka. Can you open ni kan sekarang ni is the third ni this one now the third apa ni? Can you go to the output on the left? The output on the left. Ni. Dekat you punya output yes. Yes, that's right. Okay, so this is our data when you head. Yeah, head. This is the first 6. Okay, go to the next one. Okay, this is the tail data. 195 under 200. Okay, then you go to dim. The next one. Yes. Okay, dim mean yang 204. That means there are 200 rows, 4 variables or 4 columns. Boleh? That's the dimension of our data. Boleh? And then STR stand for data structure. Okay? STR stand for data structure. Okay, and the last one, dia tanya check missing values. Sum is NA DT. Adakah your data has not available data? The answer is 0. Okay, nampak the last one tu, the last line? 0. Yeah. So that is why if you want a clear output, you separate your code each line so that it's not hiding in the outputs. Okay, can you separate that? Let's try separating that. Create a new yes, I'll skip first. Yes, create a new one first. Okay, so you buat 3 kot, 3 ke 4. 1, 2, 3 tambah 3. Yes. Yeah. Okay, banyak-banyak pun tak apa. So that you understand the dia punya itulah output dia. Okay, good. Okay, then you run again. Oh, macam dah terpadam tu. Sekejap. You dah terpadam. Okay, good. Okay. Then you run. Okay, so it is much clearer. Itu tail head dengan tail pun kalau you nak, if you want to separate head and tail, also possible. You know, head and tail, I put a semicolon there in the code. You can still separate it. And then get rid of the semicolon. Yeah. Okay, good. You got the ni dah. Okay, you had the head, the first 6. Yeah. The last 6. Yeah. Tail. And then dimension, 200 by 4. That means 200 rows times 4 columns. You have the 200 observation for each variable. There are 4 variables. Okay. And as structure, dia kata kita nak tengok apa how is the data is being recorded. Yeah, it is being recorded in a data frame feature. Yeah, data structure. So you have 200 observation times 4 variables. So the variables names are YouTube, Facebook, newspaper, and sales. Yeah. So these are actually the data is about marketing data. It's about they put budgets to advertise their products. Yeah. Using newspaper, the medium of advertising medium using newspaper, Facebook, and apa satu lagi? Facebook and apa ni? Yeah, okay, Facebook and YouTube. Okay, so yeah. Okay, for the head and tail, further up, can you go further up? Actually, you can control, instead of looking by default 6, can you put a comma beside DT? Head, DT, comma, ni dekat 68, line 68. Okay, situ pun boleh. Let's say you put it 50. Yeah. Okay. Itu kena pergi the next row ni. Yang ni. Itu baru 10. And then you go to number 2. Yang on the right tu. Bawah on the right. Yes. 2, 3. Yeah. Okay. And so. Okay. Kita nak 50 ya. 50. Ini tail lah. The last 50. Yeah. And similarly for head. Yeah. So in other words, if you just use head, by default only 6. Yeah. The first 6 or tail the last 6. But you can control it. If you want to see more data, yeah, you just comma how many you want. Okay. Okay, boleh. Any question? Is everybody okay? Boleh? Any question? Okay, then we can move on. So this is step 1, okay? Step 2, so this problem has no, this data has no problem. There's no missing data. Okay, step 2 will be to summarize the data. Okay, so we consider this step. Oh, sorry, okay. Okay, I need to share my screen. Okay, I'm using up. Okay, step 2 will be to, okay, the same data. Yeah, I'm lazy to write at marketing and so on. So I rename, instead of marketing, become only DT. Okay, so DT, and I get the summary. So this is the summary of my data. Yeah, so I know that the minimum is 0.84. Yeah, first quartile, second quartile, the average, yeah, the third quartile, and also maximum. Yeah. So if we use a summary function, this is called function. Yeah. So we only have 1, 2, 3, 4, 5, 6 descriptive statistics. Yeah. Or 5 summary. Okay. For Facebook, newspaper, and sales. Okay. And we have another function that is called describe. But you need to load this library as usual. Go to install. Then you type PSYCH. Okay. Then install. Okay. Once you have complete the installation, then you go to library and then use the function describe. Okay. So you can see that if you use the function describe, you get more information about the data. You have how many variables you have in the data. For each data, how many observation, the mean for each data, the standard deviation, the median, the trim, the mean absolute distance, yeah, and minimum, maximum, range, skewness, and kurtosis. Okay, so this is the numerical descriptive statistic, numerical description for the data. Okay, so from this data, you can see that the mean, yeah, the mean for YouTube is 176, Facebook 27, yeah, and so on. The sales 16.83. This is, I think, in thousand, yeah, thousands. Okay, the standard deviation. Yeah, normally we are also interested in the standard deviation. Okay, so if we are using YouTube, the range is higher, yeah, as compared to using Facebook newspaper, yeah. So this is the standard deviation for the sales. Okay, how are you going to calculate variance? Because in this summary, they only give you standard deviation. How are you going to calculate variance for the data? You know what is variance?
Square the standard deviation.
Okay, good. So you just take the square of the standard deviation. Okay, for example, let's say this one, to find the variance is simply, you write maybe variance YouTube, UT. So you just take, okay, and then just square it. And then call it VR variance of YouTube. And then run it. Okay, so 10,615.18. Yeah, so that is the variance for the YouTube and so on. So you do the same. Okay. Okay, what is the next step? So that is the second step. Do the numerical description. After that, this is the interesting part. We plot, the data. Since our data is all quantitative data, and it is continuous, So you do a histogram for discrete or continuous data as long as it is quantitative data. So you can plot. There are many. I show a different types of plot for each variable, and then from there we can compare. Yeah. Okay. So So just this is step 1, step 3. Yeah. Okay. So plot. Let's say we have histogram. Okay. So dia akan bagi gitu histogram. Okay, and if you want a bigger one, you can zoom in. Yeah. Okay. Now remember, just compare. Just look at this y limb. Y limb, that means I want my y-axis to be the same for all of this, so that I can compare. Yeah, all of these plot. Okay. So if you want to export, you go to copy to clipboard or save image, pun boleh. And then you can update if you want to more. If you want to increase the height of the graph, pun boleh. Let's say 400, and then you update preview, so you have a better shape of graph, okay, of histogram. And then you copy plot, or boleh copy plot, and then put in your document. But if you are doing it in our notebook, it will automatically display the output below your code. Okay, or you can also save an image. So you use your directory, where you want to save your image, and also you can rename. Let's say histogram 1, something like that. Okay, then save as usual. Okay, so okay, so I can run for Facebook, draw a histogram for Facebook. Okay, for newspaper and for sales. Okay, and actually I can adjust. Adjust because the title on the top is auto histogram of data sale. For example. So I can change that. For example, I change the sales to histogram. I should put xlab. Main the main title of this plot. Okay, histogram, and then I put it sale there. Okay, run again. So I change that. And similarly, you can change the X label, X axis, and Y axis. Y axis punya apa? X lab. Lab equal to, and then I put sales. Let's say sales. So this is in million, in thousand, sorry, in thousand. 000. For example. And then don't forget the apa ni. Okay. Okay, boleh? Any question? Can you follow that? Is it all right? Hello, is it okay?
Okay, Doctor.
Boleh ya. Mohsin, are you okay, Mohsin? Mr. Mohsin?
Okay, doctor.
Okay, good. So you are in UMP?
Yes, doctor.
Okay, good. Okay. Okay, now I have another function here that is called par. Okay, this one we can combine, yeah, where it is easy to compare the graphs, yeah. So let's say you can clean your screen by, okay, of course, in your case, your output is below your code, yeah, not like mine. Okay, you can use par m, that mean matrix, yeah. This is the format, so you can see. Can you see that? So it become in one. I want to zoom it in one place. Instead of separately. Okay. So you can put it together. Yeah. So you can see the distribution. Yeah. Okay. Of course, there is a lot of more features in in R on how do you beautify, how you change colors and so on. Yeah. I think you can change colors here. Let's say if I write color, I'm not sure. Yeah, I forgot already. Maybe blue. Okay, see whether it is working or not. Yeah. I don't remember all the codes. Yeah, normally I just Google, yeah, to do whatever I want, yeah, to the graph. But I have the basic codes. Okay, so you can play around with the changing the titles, changing the label for XLab. If you want to change the title for YLab is also possible. Yeah, you just use YLab. Yeah, for example, YLab equal to, let's say, maybe we want to change it into probability. Okay, so we need to add probability equal to true. Okay, because sometimes the histogram, right? Yeah, histogram is not in, okay, equal to, what is it? YLab, betul. Oh, istilahnya probability. Right. Probability. YLab probability. Okay. Where is it? Main. Seal, lab seal, YLab. Okay. I'm not sure why it's not working by right. Okay. Okay. Okay, and I could, like I said, I didn't remember, yeah, all of this code. Normally I will check, yeah. Okay. Okay. Actually, I need to get the density, but then apa ni? Okay, true. Okay, so how do we put? Yes, most of the time you see when people draw histogram, they put a line, isn't it? A density line. Yeah, PDF. Yeah, the fitting line, yeah, or the fitted line. Okay, so we can include that. Yeah, you can change the color if you want. Yeah, and so on. So even the line type you can change, but again, I didn't remember exactly what is the number for. Wait, kita try again. Okay, yeah. Number 5, LTY equal to 5, it give a dotted line. Yeah, dash, dash, dash line. And even you can make it thicker, LWD, line width. Yeah, maybe 2, see what happens. Okay, so it come thicker, clearer. Okay, is it all right? Any question? Yeah, the plot is very nice, isn't it? I know, I find that it have a very nice histogram. Yeah, plot of histogram. Very clean, very clean. Okay, of course, like I said, you can change the label, the X label, the Y label. Okay, and even this one, you can put it at 0. Yeah, but again, I couldn't remember the code. Yeah, I need to check. Actually, it can touch 0 and 0 can be, we can overlap it. Yeah, so there is it's a nice axis. Okay, any question so far? Boleh?
Boleh, Doktor.
No, doctor.
Okay, good. Okay, what about the girls? Is it okay? Nora Fira, Siti Fatima, Nur Sofia. Is it okay?
Okay,
Siti
Doctor.
Nur Izzati, boleh? Okay. Okay. So how do you find so far? Is it a nice, have you ever draw this kind of graph before? In your study? I mean, in your research, have you done that?
No, doctor. This is the
No.
first
No?
time.
Sorry?
Yes, but using Excel only, Doktor.
So now you know R is very quick, isn't it?
Yes.
Yeah, using Excel, of course lah dia dah boleh apa ni, tapi what is important is apa ni, R ni dia, you can easily change, yeah. You can easily change beautify it using a function, yeah. So there's a lot of packages, yeah, outside there. So like I said, you can just Google it or use ChatGPT. Ask ChatGPT what you want to do with your apa ni, with your histogram. Okay. Okay, let me try asking ChatGPT on how we make sure that our graph is apa ni, have a, wait,
Doktor.
yeah,
Can you explain again about the bar, the line 37?
57,
37.
37. Oh,
The
bar is
bar.
how are you going to arrange your data in one place? Bar 2 by 2 maksudnya 2 rows, 2 column. This one. Boleh? Since we have 4 plots,
Okay.
you can change this to, let's say, 1, 4, because we have 4. I mean, 1 row for 4 columns. And the second one is column. The first one is row. Yeah.
Okay.
Okay, let me show you. Can you see that?
Yes, Doktor.
Yeah, but of course not nice, kan? Yeah. Yeah. So you can put side by side, or you can put in a row and columns. Yeah. But it's a good question. Yeah. Okay. And then the next one would be, so you can play around with histogram. Okay. Is box plot. This is, I like box plot very much. Yeah. What can you tell me? What is the limitation of histogram? Apa limitation of using histogram? If you have three variables, can you overlap it on top of one another? 2 histogram, if you overlap, it is okay. But if you have 4, can you see what's going on? Do you get my point? You have 4 histogram. You want to overlap on top of it. Yeah. So you cannot see clearly, yeah, what's wrong with what is in the data, isn't it? But if you are using box plot, yeah, you can see the data in one go. So that is why I like very much box plot. Do you know what is box plot? You know what is box plot?
No, doctor.
No, doctor.
Yes.
Okay, box plot is actually a box and whiskers plot. Sometimes people call it a 5 summary plot. Have you seen this before? Have you seen this plot before? Yeah, I need to clear this first.
Yes.
Have you seen this plot? Yeah.
Yes.
Okay, have you seen this? And you can arrange this, alter the orientation of this. Maybe most of the time you see this kind of box plot. Horizontal, through. Okay, by default, they give you the vertical orientation of box plot. Okay, but you can always change it. Okay. Okay, you can do individually for YouTube, for Facebook, for newspaper. And you can also, this is the best part. Yeah, you can compare it all in one go. How the data is being distributed. Okay. You know how to read this diagram or this plot? You know? Like I mentioned just now, if you use a histogram, if you want to compare the sale based on this advertising media, different media, your histogram will be crowded, isn't it? But using box plot, yeah, it is well presented. You can see it, the distribution of your data, yeah, in one go. Okay, so this box plot, okay, if I take one, one, okay, just to explain this one, yeah. Okay, let me run that one. Okay. Now, like I mentioned just now, this box is called a box plot, or sometimes it is called box and whiskers, or 5-number summary plot. Yeah, why 5-number summary? Because this the point on the left, this is the minimum value. Okay, the age in the box too, the left side of the box is the first quartile, Q1. Okay, the one with a darker line, a bold line, is Q2, the median. And the left side of the box is Q3, to the 75%. And this is the minimum. Yeah, on the far right is the minimum value. Okay, so from this box plot, we can see how the data is being distributed. Okay, we look at the median. If the median is on the left, yeah, it is right skewed. Okay, so in the box plot, it doesn't show the mean. Yeah, but sometimes some box plot they do show, but they have a different code. But for this code, there is no mean shown on the box plot. Yeah, because actually box plot is drawn based on the arranged data. Yeah, that means if you draw box plot manually, you need to arrange your data first, ranking your data from lowest to highest, or the other way around, highest to lowest, and then you find minimum, maximum, and then you identify your first quartile, second quartile, and third quartile, and you draw this. Okay, but now we are lucky. We have a code in R which automatically draw the box plot for us. Okay. Okay, another feature about box plot. Which one we have outlier just now? No? Yeah. Okay, another feature, I want it to be horizontal. So that it is consistent with the top one. Okay. Okay, if there are outliers, that mean value that is beyond the maximum value, or the value that is extreme, yeah, as compared to the rest of the data, yeah, this is it will show in box plot, yeah, with the dot here. That means these two values are outliers, extreme values. Okay. If maybe in your case, if you got this kind of data, you need to, do your or repeat the experiment or repeat the measurement. Yeah, for example. Yeah. Are you encounter this kind of problem while you are doing your study? That means you finally suddenly got extreme values and you need to repeat the experiment and so on. Have you experienced that?
Yes.
Yes, yeah. But actually, when we do the preliminary analysis, yeah, these are the things that we want to pick up, yeah, from the data. Yeah. Yeah. If there is outlier, that means, okay, these 2 points you need to find out why it happened. Maybe you need to calibrate your weighing scale or your tools. Yeah. To ensure that, the data is good enough. Yeah. Before you proceed to the next level and so on. Okay. So that is basically the 3 steps in or we summarize graphical analysis. Okay, before that, numerical. Okay, so this part we use graphical as normally we use histogram or box plot. This is for continuous data, quantitative data. For qualitative, you need to use bar plot, pie chart, and so on. Because we are using this data, they are quantitative data. Maybe next time we try using the qualitative data, then we see how we draw the box plot and so on. Okay, now the third step will be how we're going to check the relationship that may exist between these 3 variables. Yeah. So we use the term correlation value. Okay. Have you ever used correlation before? Ada tak? Any of you?
No, Doctor.
No. Okay. So we copy this first. Okay. So the correlation mean we want to check, is there any relationship? For example, maybe you're in your case, temperature and pressure. What happened to the yield in your experiment? Yeah, what happened? You have, if you put pressure and you put, you change the temperature, what happened to the yield? Yeah, so you want to see, using correlation, you want to see this relationship. Yeah, so for example, I check for correlation between sales and YouTube, so 0.8. Yeah, between sales and Facebook, 0.7. Correlation sales and newspaper, is very low. Okay, in correlation, the closer the value to 1 or to -1, that means the correlation is strong. Or in other words, the relationship between one variable to the other variable is strong. Yeah, if it is closer to 1, that means strong positive relationship. If it is close to -1, it is negative correlation, a strong negative correlation. Okay. If it is closer to 0, it is, we can say that it is weaker, or if it is 0, then no correlation. Yeah, that means if you change the temperature, it is still the same. That means by changing temperature has no effect on the yield. Yeah, for example. Yeah. And instead of finding the correlation for each at a time, you can write core dt. So it gives you a matrix. Okay, a matrix, a correlation matrix. Okay, if you want a better value, or actually if you want to round off, yeah, round to some decimal places, you write round. Yeah, okay, let's say you only want to 4 decimal places, so it is more nicer. Okay, so you put round function and then comma 4. If you want only 2, comma 2. Yeah. So this function round, that means it gives you how many decimal places you want your data to be. Yeah. Okay, looking at this value, which correlation is the highest? Which one? Between what and what? Okay, which correlation value? And tell me the variables involved. Which variable has the highest correlation? Which one? Which variable? Siti Fatimah? Hanif?
Don't know, doktor.
No. Kita tengok yang paling closer to 1. So this will be, sales will be the strongest correlation between YouTube. In other words, YouTube will give a strong impact on the sales. Yeah, but if you look at newspaper, yeah, newspaper and YouTube, 0.05, yeah, close to 0. So the correlation is not strong. Yeah. So between sales and Facebook, it is less stronger than YouTube, but it is kita panggil moderate, yeah, moderate relationship. Sales and newspaper, okay, it's closer to 0. Okay, this one weak. Yeah, or almost no correlation. Yeah, so that is how we look at it. Yeah. Yeah. So we look for, okay, between itself, of course, 1. On the diagonal one, it is always 1. Yeah, the correlation between themselves. Yeah, newspaper sales and sale. Yeah, the correlation, of course, 1. Yeah, on the diagonal part. Okay. Okay, we can use another function that is called rcore, but you need this library, HMISC. Okay. Then, okay, this one, because sometimes bila kita buat correlation, some paper dia nak dia punya hypothesis. Okay, apa dia punya hypothesis? So this is the p-value. P-value, yeah. So now the significance of the correlation value. Okay, the significance. So if it is 0, then it is significant. The correlation, yeah, is not 0, or is strong and also significant. Yeah, this is the hypothesis testing part. Yeah, P means p-value. This value is p-value, this one. Okay, So if you want something to be significant, p-value must be less than alpha. Yeah, alpha is the significance level. Like if it is greater than 0.05, then it is not significant. Yeah. So that means relationship between YouTube and Facebook, YouTube and newspaper is not significant. Yeah, because it is greater than 0.05. Yeah, but if you look at sales and YouTube, sales and Facebook, sales and newspaper, yeah, there is a significant relationship, yeah, between the sales using YouTube, using Facebook, and also using newspaper. Yeah, but there is no relationship between no significant relationship between Facebook and YouTube, Facebook and newspaper, and so on. Is it okay, Polika?
Doktor boleh ulang balik yang tadi, yang significant tu.
Significant? Okay.
Uh-uh.
This P here, do you know what is P value? When you do hypothesis testing, H null. Sorry?
Doctor said just now is significant value.
Okay. Okay. This P here must means that P value. That means this value in this matrix is a P value. Okay. Something is significant if the P value here, this is P value, P value, I mean from the hypothesis testing. Okay, if it is greater than 0.05, okay, rule of thumb kita punya alpha is 0.05. If it is greater than 0.05, that means it is not significant. Yeah, that means the relationship between YouTube and Facebook is not significant. Yeah, boleh faham ke? That means tak ada YouTube pun tak apa. Tak ada for Facebook pun tak apa sebab relationship is not significant.
Faham, Doktor?
Okay? Okay, if it is 0, yeah, or less than 0.05, that means relationship is significant between sales and YouTube, between sales and Facebook, between sales and newspaper. It is significant because the value or the alpha value is less than 0.05. Yeah. So this is interesting function. Yeah. If core, for core, yeah, kalau R core ni, it give you, sorry, what is it? It gives you not only the correlation matrix, this is the correlation matrix, but also they provide the p-value, the significant test for correlation, the hypothesis testing for the correlation. If you use core function, it only gives you this part, the correlation value. Yeah, tapi R-core, it gives you the hypothesis testing for the correlation value. Okay, that's a different. Yeah, because the function is different there. Yeah, cuma you need to be careful that your metric, your data frame tu must be has matrix. Yeah, so you need to change it lah. Okay, boleh.
Boleh, Doktor.
Okay, next is this is interesting. We want to see how do we plot this relationship. Just now, just numerical value, isn't it? So if we take this, so maybe this one you need to install quite a number of packages. Recently, I just have one student from University Malaya. He want me to help him with statistical analysis. He's in zoology. So when I draw this kind of graph, he's very excited. Yeah. All this while he's been using Excel to draw his graph and so on. Yeah. So this is called parallelogram. That means we draw a picture instead of numerical. Yeah, this is numerical. So we want to draw. How do we draw that? First, we need this package ggplot. Yeah, itu library core plot. Yeah, by right. This one should be come above this. Okay. if you didn't have this, you need to install it first, as usual. Go to packages and then install. So you write core, CORR, plot. Okay, then install as usual. Yeah, after you install, then call it library. Then you got it. Okay. Oh, tak ada pula ini mesti kat atas je. Saya lupa nak install. Okay. Ada yang tak apa ni lah. Cannot find GG core plot. Okay. Maybe there must be apa ni? Maybe not this one. Okay. I forgot where I put it. Oh, okay. Maybe here. I'm not sure which apa ni? Sekejap ya. I go and find in apa ni? In this. Package in R. Which package? Oh, GG. It is called ggplot2. Okay, ggplot2. Okay, so I'm going to go to install. Install. Okay. Okay. Dia dah pening ni. Sekejap Library. ggplot. Maybe I need to close it first. Sekejap I think I need to apa ni? Library. Okay. Sekejap I will okay, I will save this first. ggplot2. Oh, ggplot. Okay, let's try. Cannot be uploaded. Cannot be. Wait. Ggplot. Ggplot. Okay, but it's okay. We look at. I will try to resolve that. Okay, we look at the other. Apa ni? The other software, because there are many examples that I give here. Okay, let's try this one. Core plot instead of that. Yeah, you can draw this. Very nice, isn't it? This is graphical. So in the middle, on the diagonal is actually when you see in apa ni 111 tu. Yeah, the correlation between is themselves. Yeah, that is the apa ni, the diagonal on the diagonal. And the bigger circle mean that means the stronger, close to 1. Okay, blue, that means closer to 1, that means very strong. Okay, if it is to the negative part, yeah, if I can zoom this. Yeah, if it is brown in color, that means it is negative direction. But if it is darker, that means it is strong negative correlation. But in this case, only on the positive side. That means strong positive correlation. Yeah, the bigger circle mean stronger correlation between YouTube and sales. So in other words, in the marketing, they should use apa? They should use Facebook or YouTube to increase their sales. Huh? Which method they should use to increase the sales? Hello?
Do you
Which
understand,
method?
Doctor?
Huh?
Do you understand?
You don't understand. Okay. Okay, this plot shows the correlation. How one value behave based on the other value. Okay. Kalau this one, if the circle is larger, that means there is a strong relationship between sales. So when sales increase, so has the YouTube. When YouTube, yeah, they spend more money on YouTube advertisement. Okay, the sale is also good. Okay, because it is closer to 1. That means there's, the relationship. Maknanya YouTube effect the sales. Okay, boleh?
Boleh, Doktor.
The cell that doesn't have nothing, that mean kalau diguna Facebook, yeah, the sale is not that much. Yeah, as compared to if they are using YouTube or using Facebook. Yeah, sorry. Okay, and newspaper memang out lah. Okay, tapi sales dengan Facebook very good. Yeah, sales ni with Facebook, okay, tapi not as good as YouTube. YouTube is better. Okay, because dia lagi pekat tu. Boleh ke? Okay, so kita boleh pilih lah daripada tu. Okay,
Doktor,
then
maksudnya abaikan yang bulat yang paling besar tu, yang paling gelap
yang
tu.
besar ni dia sebab dengan diri dia sendiri. With himself.
Okay.
Yeah, YouTube and YouTube. Of course lah. Memang strong correlation lah. All of this is 1. Ni in the matrix ni, yang diagonal ni always 1. Yeah, because it is between themselves. Yeah, YouTube between YouTube, Facebook between ni memanglah strong correlation kan. Yeah.
Okay, Doktor.
Okay. And then more plot, pairs. Okay, more plot. So yeah, this one you can see in one go. YouTube, Facebook, newspaper and sales. Yeah. So yeah, kita nak yang ada trend. Sales and YouTube, you can see there is a good trend there. Yeah, increasing trend. Yeah. When sales is increasing, so has the YouTube ni. Bila kita spend more money on YouTube, on the advertisement using YouTube, the sale is increasing. Yeah. You nampak trend dia. Yeah. But YouTube and Facebook, there is no specific trend on the data. Okay. Serabut. Yeah. Facebook and newspaper, looks like there is a trend but not clear. Yeah. So not good. Yeah. And so on. Okay. More feature of correlation matrix or correlogram. This is a combination of many things. Yeah. So they look at histogram in the middle. This is the correlation values. Yeah. So this one that is stronger in between sales and YouTube. So consistent lah. Okay. And then more. Ini pun tak boleh. Dia memang kena apa ni, ggplot ni. Okay. So I need to install this back. Okay. Sekejap. Saya cuba install. Okay, you can install that way or gunakan package and so on. Okay. Oh, ada lagi yang tak ada ni. Kalau tak ada tu kena install dululah Fable Tools and so on. Ya, oh dia nak ggplot ni, tu ni. Okay. Dah install jugalah ggplot tu ni. Dia ada error. I don't understand why there's an error there. Okay, but I'll check later. It's okay. Okay. Ni pun error. Tak tahulah. Okay, but at least you get some of the plot there, yeah, that you can use to generate the apa ni? Oh, dia dah apa ni, haywire dah tu. To generate the correlation plot. Okay, boleh? Boleh ke?
Betul.
Yeah.
Can we go back to the yang bulat-bulat tadi?
Aha.
Uh,
Saya
yang
punya
bulat-bulat tadi kan
Aha.
dia ada yang negatif dengan positif kan, dia tepi tu.
Aha.
Yang tu maksudnya lagi kurang correlation ke apa?
Sekejap ya. Yang mana ini ya? Ini ke? Lah, dah tak jumpa pula. Ada ni. Dia pening ni. Which one yang tadi tu ya?
Before this.
Ini ke? Boleh tak? Ini. Okay, this one. Okay. What do you mean?
Dekat yang newspaper yang bawah ni,
Aha.
dia ke bawah yang dia dekat negatif, yang hampir dengan negatif tu kan?
Aha. No, you tengok colour. You tengok colour.
Oh, tak colour je.
Yeah, you just observe the colour.
So
That
the value
mean,
indicate apa?
Sorry?
Oh, faham.
You just look at the colour. This is the colour scale. That means in this graph there is no brown or orange colour, isn't it? That means there is no negative relationship. Hanya positif sahaja dia punya correlation.
Oh, indication untuk colour je lah.
Yes, indication of colour je scale dia.
Okay, thank you.
So if it is darker, that mean strong positive. Kalau you ada colour of apa ni, brown colour ni, that mean dia negative correlation. But in this case, in this data, there is no negative relationship. Yeah, only positive relationship exists. Yeah, in this data. Boleh?
Okay, boleh. Terima kasih, Doktor.
Okay, but some variable is not strong. Yeah, tak ada no strong relationship. Okay. I'm not sure why my apa ni not working very well today. Okay, so that is the 3 steps, yeah, of EDA, exploratory data analysis. Okay, I need to check again the codes here. Yeah, maybe some of the apa ni library is not there. Okay, now correlation and linear regression. Can we apa ni? Boleh tak kita break sekejap? 5 minutes, is it okay?
Boleh, Doktor.
Kita break sekejap before kita masuk new topics. Ya, dia minta I boleh check sekejap lah. Dia punya apa? Maybe 10 minutes ya, dalam before apa ni? Like 11 ke kalau nak pergi apa ni? Minum ke nak pergi toilet kan so. Okay, we come back at 11 ya. Okay, can we continue? Can you continue?
Yes, Doctor.
Boleh ya? Okay. Okay, now we want to move on to correlation and regression. Okay. Okay, actually we have talked about correlation just now. Okay. In the EDA, yeah, in the exploratory data analysis. Okay. Basically we have 3 steps for data analysis. First, we look at the data, check for missing values. Yeah. The dimension of the data. Yeah. How long? How many observation? How many variables? Yeah. And then we plot. Yeah, using numerical and graphical analysis for to summarize our data. Yeah, using summary, describe, and then we use graphical analysis like histogram and box plot. Yeah, to summarize our data. And then finally we look at the relationship, yeah, iaitu correlation between the variables. Okay, now how are we going to apply correlation and linear regression? So we know that in many problems, yeah, in a real life problem, there is a relationship between variables, yeah, like I mentioned, between pressure and temperature. The higher the temperature, pressure will be lower or higher? Physics. If the temperature is low, yeah, the pressure will be what? Lower or higher? If you go up the hill or you go to Gunung Kinabalu, temperature dia rendah kan? Okay, it's colder and colder. What about the pressure? Is it increase or decrease? Okay, maybe you say you need to look at the data and so on. It's okay. But in other words, there is always a relationship, yeah, between variables or between the data that we collected. So correlation and regression or linear regression is a common method, yeah, used to investigate the relationship between variables. Basically, we have independent or the predictors and dependent variable, which is the response variable or outcome. Okay, independently, input variable. Dependently is like an output or outcome. Okay, so the question this is okay, excuse me. It's used to identify relationship between the variable, yeah, whether exists or not. And another thing is to quantify the strength and also direction. Yeah, correlation value, they give you the direction and also the strength. Okay. Just now when we see that when the correlation value is closer to 0, that means there is no significant relationship between the two variables. Yeah. And we see just now from the blue dot tadi, yeah, blue. If it is greater, it is closer than 1, that means the strength is very strong. Yeah. Dan dia give a positive direction. Yeah. So in the example just now, we can't see any negative relationship because there is no brown circle, yeah, in that plot. Okay. So actually regression is simply the mathematical expression, yeah, and how we quantify the relationship between X and Y, between the independent and dependent variable, yeah, in the form of X. So actually regression is simply the mathematical expression or mathematical equation on how we relate between the variable, between independent and dependent variable, or between predictor and response variable. Okay. Alright, correlation coefficient denoted by R for sample correlation and rho for population correlation. Yeah. So the correlation value is simply between -1 to 1. That is why I said the further the value to -1, the closer the value to -1 or closer to 1, that means strong correlation. Yeah. So correlation coefficient gives the strength and direction of the linear relationship between dependent or response variable y and dependent variable or predictors, yeah, x. So normally in most cases we have many independent variables, yeah. So if r closer to 1 or -1, the correlation between the variable is considered strong positive relationship or strong negative relationship respectively. Closer to -1, negative relationship. Strong negative, closer to 1, strong positive relationship. Okay. So to calculate correlation coefficient, the two variables must occur in pairs. So whenever we want to calculate the correlation value, they must be in pairs. Maksudnya the number of variable in X must be equal to the number of variable in Y, yeah, in pairs, yeah, dalam pasangan. Okay, positive correlation means if one variable consistently increases with increasing value of the other. So one value is increased, so as the other value. That means both are increasing. So it shows by the positive correlation. Yeah. If the negative correlation, they're opposite. If one constantly decrease, the other increases. Yeah. So they are the orang kata opposite relationship. Note that correlation does not imply causation. That is, if two variables have high correlation, it does not mean that one variable causes the value of the other variables to increase. Yeah. Relationship between variables can be presented graphically using scatter plot. So we can use. Have you heard about scatter plot before? Pernah dengar? Have you ever? Pernah? Pernah ke?
Pernah.
Pernah scatter plot X dengan Y je lah. Okay. Lajunya. Okay. Okay, another interesting feature from R is if you square that value, yeah, R squared, yeah, it is called coefficient of determination. Yeah, ambil R and then we square it. Yeah, big R mean it is population correlation. Yeah. So for the coefficient of determination, this is another value. So if it is always positive, but you square it. So just now for correlation coefficient, we have between -1 to 1, but coefficient of determination between 0 to 1, yeah, because we squared it. It is interpreted as the percentage of variation in the response Y variable, which can be explained by the predictors. Yeah. Okay. I need to check my notation. Yeah, I use mix-up notation here. Okay. So that is the coefficient of determination. Okay. This is the graphical explanation of coefficient of determination. Kenapa dia tak nak pergi jalan ni? How do I bring this? Apa ni? Okay, so what do we mean by R squared? Yeah, coefficient quantify the proportional variation in the dependent variable that has been explained or predicted by the independent variable. Yeah, it is squared of the correlation coefficient. Yeah, so this is the diagram. Yeah, to explain the R squared, the value of R squared. Yeah. So if yi ni is the actual value, the observed value. So we can find the total sum tu, yeah. So that is how we calculate the residual and so on. Okay, residual sum of squared to calculate RS. Okay, now we are going to use R on how to calculate our R, of course. Okay, so just now we have seen this function core. So you want to find the correlation value between sales and YouTube. Okay, between these two variables. Yeah. So this is correlation Pearson. Have you heard about Pearson? The people who first introduced the correlation concept, yeah, to the world. Okay, so if we copy this, okay, and then go to R. Okay, yeah, we are going to use the same data, marketing data. Okay, and then I'm going to round my correlation value and then find the coefficient of determination. So how are we going to interpret these two values? The first one, 0.7822, is the correlation value. Yeah, so we know that it is closer to 1. That means it is strong positive correlation, yeah, between sales and also the amount spent on the YouTube advertisement, yeah, the budget allocated on the YouTube advertisement. Okay. And then this is the coefficient of determination, 0.61. So how are you going to interpret that? Yeah. I want to go to this one. Okay. So this is how we interpret the boleh pun. Interpret the correlation coefficient. So we know that R equal to 0.7822. There is strong positive linear relationship between the sales and the YouTube ads budget allocation. Okay, so that's how we interpret 0.78 because this value is closer to 1. Okay, whereas for the coefficient of determination, we change into percentage. Yeah, what we got is 0.6119, but when we want to interpret, we need to change it into percentage. Then you say that 61.19% of the sales variation is predicted or is explained by the YouTube ads budget allocation. While, yeah, so you minus 100% minus 61.119%. The other variation is due to other factors such as Facebook, newspaper, budget allocation, and etc. Okay. Okay, can you get the points there? Boleh?
Yes.
Okay. So that is how we interpret, and I expect you to be able to interpret this value, yeah, for correlation coefficient. And if you square the value, you get coefficient of determination. Okay, and when you want to interpret coefficient of determination, you need to change it into percentage. Yeah, so yes, sales variable is that means the variable in the y value is predicted by the x values. This is the x values. Okay, berapa percent, how many, the percentage of variation in Y, this is Y, sales, yeah, can be explained or can be predicted by the predictors or the X values here. Okay, so that is how we explain or interpret it. Okay. Okay, any question? Okay, can you calculate call for maybe Facebook? Do the same, but do it for Facebook. Boleh? Yeah, just copy the code and then do it for the Facebook.
Doctor, I want to ask. Sorry. For my project, I do Spearman correlation coefficient.
Uh-huh.
If I do this coding, is it cover for both or only Pearson?
Sekejap ya. You can change actually. Sekejap kita check the formula. If you want to check the formula, just type question mark core. Ada tak dia keluar package dia? Dia sepatutnya dia keluar package lah. I wonder kenapa tak keluar ni? Okay. Can we specify the tak keluar pula dia punya ni. Dia patut dia ada dia punya apa? The details of that. Program. Wait kita check dekat apa ni? Dia guna apa tadi? Pearson, satu lagi apa?
Spearman.
Oh, Spearman. Dia apa ni? Spearman ni dia non-parametric kan? Yeah, actually you can change dia punya tu. Where is it? To Spearman. Mana dia punya coding dia? Sekejap Oh, kita boleh guna core test and then yes, we can spy. Okay, this is another one. We can write methods dia. You want to use dia by default dia Pearson. Ya, parametric test, but for ada orang yang keluar ke tadi? For apa ni, if you want to change to other, you can change it, ya. So you write methods. Where is it? Okay. Okay, let's try this one. Okay, so this is our, okay, actually, if you want your code to be smarter, you can write, this is X. Yeah, we use assignment value, DT sales. And our Y, I just rename it, rename it. DT YouTube. Okay, so I want it to be X and Y. So it is more flexible for me, So just change on the top here, Okay, so this is Pearson by default. Okay, if you want it to be Spearman, so we just write Spearman, method Spearman. Okay, so this is our data. I rename my DT sales into X and my data tube, YouTube. Then, okay, I need to call R1 R1. Okay. Kalau Spearman, dia tak nak pula method core. XY method Spearman. Why? Okay. Kadang-kadang sebab benda tu pun ya juga, ya. Sekejap, Hopefully it works. Okay. So dia a bit different sebab dia adalah non-parametric. Spearman ni non-parametric. Value. Correlation based on non-parametric. Boleh? But still it is strong positive, isn't it? 0.8. Sometimes if our data is not normally distributed, we use non-parametric metrics. Because it doesn't require for the data to be normally distributed. Normally we use non-parametric metrics, atau measurement. Because for non-parametric, it doesn't require the data to be in certain shape of distribution. Okay. Okay, boleh. Other
I
people
don't
use
know.
other methods. So
Don't
by
know.
right, actually this one's Spearman, yeah. Pearson, sorry. So if you want to use Spearman, you just specify the method. Okay. So if you look at if refer to here, yeah, dia ada Spearman atau gunakan di score test pun boleh. Okay. But it works also for core. Okay. So that means there are many functions, yeah, people apa ni. Okay, by default dia Spearman. Sorry, dia adalah Pearson. Okay, can you do the same for just now we do for YouTube? Can repeat the process but using newspaper and also newspaper and apa satu lagi? YouTube, newspaper and Facebook. Okay, so we have done for YouTube. So you do for newspaper and Facebook. Okay, can you do that? Anybody want to share? Anybody want to share? Ada? Anybody? Okay. Oh, saya kena ni dah. Okay, good. Siapa ni, Hanif ke?
Yes, Doktor.
Okay, good. Very good, Hanif. Okay, now try cuba buat untuk apa nama tu? Kita buat YouTube, you buat Facebook and newspaper. Okay, buat YouTube dulu. Sorry, buat Facebook dulu. Find the correlation for Facebook. Oh, dah buat dah. In percentage for, okay. That is called coefficient of
Dah buat,
determination.
Doktor. Newspaper yang belum.
Okay. First, how do you interpret that? So you buat untuk Facebook sales, the correlation between Facebook and sales. How do you interpret that? You got 0.78, isn't it? How do you interpret that? Okay.
The correlation between Facebook and sale show strong positive linear relationship.
Okay.
Because it near to 1.
Okay.
So the percentage
For coefficient of determination tu dia bukan
23.
correlation tau. Bukan correlation in percentage. It is a new name. It is called coefficient of determination.
Oh,
Dia
okay.
macam weightage tau. Coefficient of determination dia bukan correlation. It is a different measure. Okay, you boleh tulis dekat you punya dekat atas tu. How do you interpret that? You got 0.332. How do you interpret it? Letak bawah space ya. How do you interpret that? So you can write that R squared, R kuasa 2, R yes, is equal to 0.332. Okay, so yes. Okay, okay, so how do you interpret that? That means 33.3. Okay. Of sales variation. Okay, is explained by the apa? Yes, good. Question while berapa persen yang apa ni? Yang lain-lain. So you kena tolak lah. You need to subtract. Okay. So that means, yeah. So the relationship between apa ni sales and Facebook ni not strong, yeah, because dia boleh predict 33% aja, yeah. Facebook ni boleh predict 33% aja the variation in the sales. Yeah, the rest tu other factors. Do you get my point? Yeah, just now kalau kita tengok,
Yes, sir.
about 60% of the variation dalam Y tu is being affected by the YouTube just now. Okay, but this one maknanya dia punya effect Facebook is very low to the sale, towards the sales. You faham
Faham,
Mr.
Doktor.
Mohsin, can you follow? Boleh, Mr. Mohsin? You understand what Mr. Hanif is doing? Okay, so yeah, into coefficient of determination saya silap Asia tu. Okay, 242 punya line tu. Coefficient Fi. Yeah. Okay, good. Okay, so yeah, so you demonstrate that you understand. Okay, so the effect is only 33%, yeah, of the variation of sales variation. Yeah, sales variation is predicted by the Facebook. So dia banyak sangat low sangat lah Facebook ni. Okay, effect dia low. Yeah, because the relationship between sales and Facebook tu very weak. Yeah, very weak. Okay, good. Thank you, Mr. Hanif. So you can do similarly with newspaper, yeah?
Okay, Doktor.
Okay, thank you. Okay, then we want to draw scatter plot, yeah? Just now we look at the numerical part, yeah? Numbers. And how are we going to draw this to orang kata to illustrate with graph, yeah? How do we do to illustrate with graph instead of just numerical? Okay, what does it show in the apa ni? So we used to demonstrate the relationship, we use scatter plot. Yeah.
Doktor tak share screen.
Oh, sorry. Okay. Okay, now we want to use graphical method to show the relationship. Okay. So first, I'm going to rename my DT $YouTube and so on as X1, X2, X3, 3 variables. And then my response variable is sales. Yeah, is sales. And then I'm going to plot. So this is the plot actually we saw, the plot that we saw previously. Okay. Sales versus YouTube. Okay, and then you can put a box around it if you want, just box there. Then you draw, yeah, you can see the sales and YouTube, there is a positive relationship. Yeah, when the YouTube advertisement allocation is increasing, so has the sales. Yeah, you can see that the data is moving towards positive. Yeah, there's a positive trend, yeah, in the data. Okay. What about between sales and Facebook? Just now YouTube, yeah, sorry. Okay. So it is not that there's a positive trend, but the data is below is quite scattered. Yeah. So it shows from the value of R point berapa tadi? 0.02 Yeah, that means there is a trend, but very weak. Yeah. And similarly for sale versus newspaper. Yeah, definitely ini memang no significant pattern. Yeah, the data is scattered all over the places. Okay, there is no specific pattern or trend. Okay, so that's why it shows that the R value is 0.0 something. Yeah, I mean not strong. Okay, and alternatively, we can draw using other function. Oh, ini pun dia ada masalah packages, but it's okay. Next, nanti I try lagi ya. I'm not sure why it happened. Okay. But this graph is enough lah. If you want to put this in one place, you guna par tadi kan? You can take par. Where is it? Oh yes. Okay. Letak 2 by 2. And then you can put it here. Okay. Run it again. Okay, so X1, Y, bar plot. Okay. So since we only have three, yeah. So this is it. Boleh? You can plot in one frame. So you can see that YouTube has more effect on the sales. Yeah, rather than newspaper and Facebook, isn't it? Because there is no specific trend, yeah. The data is all over the places. Macam ni you nampak dia punya trend going up. Yeah, when we input more budget on the YouTube advertisement, yeah, the sale is increasing. So as the sale, so there is a positive trend. Yeah. So yeah, so maybe this market analysis will be done when people have YouTube and also Facebook. Yeah, so you can see that now you can check that only a few percentage of people reading newspaper physically. Yeah, maybe in the internet, yes, but physically maybe very few. So that is why it's no longer practical to put advertisement in the newspaper or to use newspaper to advertise your product. Okay, nowadays, what is the most popular medium to sell your product? Any suggestion? Yeah, you younger generation. Okay, which medium?
Doctor,
sell your
I
product.
want to ask,
Uh-huh.
what is the meaning of PCH?
Mana?
The
PCH.
online.
This is the type of point. Okay, if you didn't put
Okay.
this, the type of point dia ada banyak lah, ya. Dia panggil plotting punya code ni. Sekejap saya cuba ni. Buang dulu. Okay, saya cuba plot ini. Nampak dia punya titik dia open circle.
Nampak doktor?
Tapi kalau saya letak PCH equal to pada berapa tulis? Berapa?
19.
19. Ini yang normal lah. Kalau kita letak apa-apa, dia buat yang circle tu. Okay, actually the plots tu you boleh tengok lah. Plot dalam boleh tengok plot type of plot. Ya, in R atau plot function. In R, ya, R graphic plotting. So dia banyak lah. Macam-macam. Ini kita nampak sekejap ya. Saya cari maybe Okay, you boleh letak star and so on lah. Okay. Okay, dia boleh a circle, ya, kalau 1, 2, triangle point up, okay, and so on. Kalau kita cuba letak apa ni, by default, circle ni akan dapat kalau tak buat apa-apa. Kalau you buat 3, if you try 3, what would you get? PCH 3. PCH dia 3. Ya, contohnya. Nampak? Jadi star. Boleh? Boleh? Can zoom in.
Boleh doktor.
So itulah dia boleh ni. Ya, interesting lah. You boleh tukar-tukar. So you don't have to memorize. If you want to find something, just Google it. Yeah. InsyaAllah you will find it. Use the right keyword and yeah, you should be able to find it. Okay. Sambung sikit lagi. So scatter plot, so ada problem ni. Saya nak kena check packages tu. Nanti I give you the latest one. Okay, how do we interpret? Okay, just now I say it. So this is how you write. When you have this kind of scatter plot, you see that there is a positive linear trend between the sales and YouTube budget allocation. As YouTube budget allocation increases, sales also increase. Okay. Okay, and then we also have hypothesis testing for correlation. Yeah, we cannot simply say that sometime when the correlation is weak, it is not significant. Sometimes correlation is weak, but it is significant. Yeah. So we need to justify using hypothesis testing. Okay, the hypothesis will be rho is equal to 0. That means there is no correlation between the variable. And we are looking for rho not equal to 0. That means there is a correlation between the variable. That means if rho equal to 0, your p-value will be less than 0.05. Then it becomes significant. Bila dia significant, we do not reject the null. We reject the null hypothesis. Okay. Boleh faham hypothesis testing? Can you understand? Yeah, p-value. Okay, maybe I should write somewhere here so that it will help you to understand better. Okay. Okay, if H naught is rejected, the correlation coefficient is significantly different from 0. The correlation coefficient is said to be significant. So there is a significant correlation between X and Y. Hence, the regression line can be used to model the linear relationship between X and Y in the population. Yeah. Because when we use data, we use data as a sample. Yeah, and using hypothesis testing, we make an inference about the population from the sample. So if in the case H naught is not rejected, the correlation is not significantly different from 0. So it is close to 0. The correlation coefficient is said to be not significant. So the conclusion will be there is no significant correlation between X and Y. Hence, the regression line cannot be used to model the linear relationship between X and Y in the population. That means the mathematical model that you form is not suitable because it is not significant. Yeah, that is the effect. Okay. Okay, kita sambung sikit lagi. Okay, untuk statistical modeling. Okay, then kita boleh continue next week lah. Okay, statistical modeling process, yeah. So just now, we see the basic, before we do any modeling. We need to understand the relationship between the variable, looking at the correlation and regression, yeah. So statistical modeling. Okay, what is statistical modeling? Statistical modeling is simply the technique of applying statistical analysis or statistical method that describe the underlying structure of data. So a statistical model is a mathematical representation actually. How do you relate between the two variables or between the variables? Yeah, so that is called using statistical model or a mathematical model. Yeah, remember that statistics is a subset of mathematics. Yeah. So statistical modeling is a powerful technique used in data analysis to uncover patterns, relationships, and trends within data set. Okay, yeah. So, but whenever you have data, yeah, try to use statistics, yeah, to observe the pattern, the relationship, the trend, yeah. In other words, to get the insight of the data. Okay, dia kata, by applying statistical method and model, researchers analysts can gain insight, make prediction and support decision-making process. Yeah, so your decision is not purely on your intuition. It is based on the data, or it is called data-driven decision making. Okay. So statistical modeling involves identifying the variables of interest, selecting an appropriate model, estimating model parameters, and we need to assess the goodness of fit, how well the model fit the data. Okay, so there are basically three key steps in a modeling process. Number one is formulating the mathematical model. Yeah, we need to construct the mathematical model. Secondly, to construct model predictions, yeah, by predicting the parameters, and the third one will be to validate the model. Okay, so what is formulating the mathematical involved? Identifying the type of relationship between the variables and selecting an appropriate model based on the underlying structure, because sometimes the data is not in linear relationship, it is in curvilinear. Yeah, and sometimes it is not between one-to-one relationship. Sometimes between one to many. Yeah, variables. Yeah, so it is different formula. So common model include linear, polynomial, and logistic regression. It depends on the nature of the dependent and independent variables. Yeah. Okay, and then we construct model predictions where it involves estimating the parameters of the model. Okay, so this is typically done using technique like least squares for linear regression. We use MLE for generalized model or other appropriate methods depending on the model type. Yeah. So the goal is to fit the model to the data by adjusting the parameters so that the predicted values are as close as possible to the observed data. Okay. Maknanya from first step tu, we got the model. Once we identify the model is good, we need to find the suitable parameters, or actually the weight, yeah, for the model. Okay. So yeah, and then to estimate the parameters, kita gunakan least square methods or MLE. Yeah, and of course there are many more method, yeah, to estimate the parameters. This is few, to name the few. Okay, once we have that, we use goodness of fit test, yeah, to measures like R squared for linear, or the R squared value that we calculate, we can tell something about the goodness of fit. So if R squared is close to 0, R squared, yeah, that means the percentage to close to 0, that means good fit, it is not a good fit. But if it is close to 100%, that means very good fit. Okay, that means in other words, the mathematical model or the statistical model is correct for that particular data. Yeah, goodness of fit. Yeah, that means it shows the differences between observed data and also the data that we predict. Yeah. Okay, and then we also have residual analysis to validate our data. We examine the differences between observed and predicted values, the residual, to get the residual actually, and to ensure that assumptions like normality, independence, and homoscedasticity are satisfied. Okay, and the third method will be to do cross validation. Normally cross validation ni kita gunakan apa ni? Kita split, ya, kita do splitting, data splitting. Kita save most of the data for testing and the small part for training. Okay, so this is how we do cross validation. Like in my case study, I do rainfall modeling. I don't have to do cross validation. Yeah, just take all the data and then model it. Yeah. So it depends on the type of case study that you did. Yeah. Like if you use time series modeling, they require you to do cross validation. Yeah. Okay. Okay. Any questions so far? Any question?
No, doctor.
Okay. Good.
No, Doctor.
So, okay, we just finished this. Then we can continue with the example. Okay, very quickly. Okay, so we are going to focus on simple linear regression and also multiple linear regression. Okay, so what is simple linear? Is simply one y, one x, one dependent variable, one independent. That is simple. Yeah. So what is the requirement? Requirement that the random error is normally distributed with mean zero and variance sigma squared. Okay, and we can estimate. Yeah, the estimated model. Where we call it line of best fit is y hat equal to beta naught hat plus beta 1 hat x. Have you seen y equal to mx plus c equation during your school days? Y equal to mx plus
Yes,
c.
Doctor.
Yeah, so it is similar. It's just that in this case, they use different notation. Yeah, instead of C, they use beta hat naught. And then instead of M for the slope, they buat beta 1 hat. Yeah, so yeah. Okay, so this is the illustration. Yeah. So the black dots is actually the observed data. Okay. The blue one is the mathematical equation that relates this data. Yeah, regression line is simply the mathematical expression or the statistical model. Yeah, so that is why it is very smooth. Yeah, kalau if it is observed, of course there is a gap. Yeah, in between. But if you draw a straight line or a line between the observed two, this is actually a predicted equation. Yeah, equation that we fit in according to the data. Okay. So that is what we want to measure. Yeah, what is the error? Yeah, how good this equation can fit in with the data. Okay, under goodness of fit. Yeah, test yang kita gunakan. Okay, first before we proceed, we need to look at the hypothesis. Yeah, for the model, is it significant? If the slope is zero, beta 1 equal to 0, that means no relationship between the variable. That means yes, we need to look for alternative. Yeah, if it is not equal to 0, that means there is a significant linear relationship. That is when you have p-value less than alpha, less than the significance level. Okay. So the code that we use just now, R core, will give you this part. Yeah, the hypothesis. Yeah, this function R core, they gave you the correlation value and also the hypothesis testing test, to the p-value. Okay, remember we discussed just now. Okay. Okay, and then this is the step to model the linear regression to model our data using simple linear regression model. We plot, then we find correlation, coefficient of determination, yeah, interpret, then we describe linear relationship, yeah. Then we conduct the hypothesis testing, yeah. Then we check for the model adequacy, yeah, then make prediction using. Then only we can confirm that we can use that model to make prediction or forecasting, yeah. Okay, I think we will continue next week, yeah, for the model adequacy and so on, yeah, and then with the example, yeah. Is it okay? We continue next week, yeah. The part.
Okay, Doctor.
Okay, so there's a lot more to be explored, yeah. But just play around with the I did supply the codes, yeah. So you can play around yeah, to see how it works and how to interpret and so on. Boleh? Okay, so banyak tu. Okay, about 63 pages. Yeah, so about apa ni? Boleh? Any question before we end our class?
No, Doctor.
Okay, so I stop sharing and I can stop recording, right? Okay, but I have to wait, yeah?